cream is a frozen blend of a sweetened cream mixture and air with added flavorings. A wide variety of ingredients are allowed in ice cream, but the minimum amounts of milk fat, milk solids, and air are defined by standards of identity. Ice cream is sold as hard ice cream or soft serve. After the freezing process, only a portion of the water is actually in a frozen state. Soft ice cream is served directly from the freezer where only a small amount of the water has been frozen. Hard ice cream is packaged from the freezer and then goes through a hardening process that freezes more of the water in the mixture. There is a wide range of ingredients and formulations that can be used in ice cream. The total milk solid components of ice cream includes both the fat and other solids. The other milk solids consist of the protein and lactose in milk and ranges from 9 to 12% in ice cream. The non-fat solids play an important role in the body and texture of ice cream by stabilizing the air that is incorporated during the freezing process. Sources of non-fat solids include milk, cream, condensed milk, evaporated milk, dry milk, and whey. Sweeteners are used to provide the characteristic sweetness of ice cream. Sweeteners also lower the freezing point of the mix to allow some water to remain unfrozen at serving temperatures. A lower freezing point makes ice cream easier to scoop and eat, although the addition of too much sugar can make the product too soft. Stabilizers are proteins or carbohydrates used in ice cream to add viscosity and control ice crystallization. Over time, during frozen storage, small ice crystals naturally migrate together and form large ice crystals. Stabilizers help to keep the ice crystals isolated and prevent the growth of large crystals. A wide range of flavorings are used in ice cream. Flavorings include natural and artificial colors, fruits, nuts, and bulky inclusions such as chocolate chunks and candies. In a manufacturing unit, they first blend the ice cream mixture. The milk fat source, non-fat solids, stabilizers, and emulsifiers are blended to ensure complete mixing of liquid and dry ingredients. Then they pasteurize the mix. Ice cream mix is pasteurized at 155 degrees Fahrenheit for 30 minutes. The conditions used to pasteurize ice cream mix are greater than those used for fluid milk because of increased viscosity from the higher fat, solids, and sweetener content and the addition of egg yolks in custard products. Next, they homogenize. Ice cream mix is homogenized to decrease the milk fat globule size to form a better emulsion and contribute to a smoother, creamier ice cream. Homogenization also ensures that the emulsifiers and stabilizers are well blended and evenly distributed in the ice cream mix before it is frozen. Next is aging of mix. Ice cream mix is aged at 40 degrees Fahrenheit for at least 4 hours or overnight. Aging the mix cools it down before freezing, allows the milk fat to partially crystallize, and it gives the proteins stabilizers time to hydrate. This improves the whipping properties of the mix. Thereon, they add liquid flavors and colors. Liquid flavors and colors may be added to the mix before freezing. Only ingredients that are liquid can be added before freezing to make sure the mix flows properly through the freezing equipment. Thereafter, it is freezing. The process involves freezing the mix and incorporating air. Ice cream mix can be frozen in batch or continuous freezers, and the conditions used will depend on the type of freezer. Continuous freezers consist of a fixed barrel that has a blade inside that constantly scrapes the surface of. The continuous freezing process is much faster than the batch freezing process. Later, they add fruits, nuts, and bulky flavorings. Fruits, swirls, and any bulky type of flavorings are added at this point. These ingredients cannot be added before freezing or they would interfere with the smooth flow of the mix through the freezer. The ice cream at this point is soft and it is easy to mix in the bulky flavorings, so they are uniformly distributed throughout the ice cream. Mixing in bulky flavorings after freezing also prevents damage to the pieces and allows them to remain whole or in large chunks. After that, it is packaged. After packaging, it is hardened. The ice cream is cooled as quickly as possible down to a holding temperature of less than -13°F. The temperatures and times of cooling will depend on the type of storage freezer. Rapid cooling will promote quick freezing of water and create ice cream crystals. Storage at -13°F will help to stabilize the ice crystals and maintain product quality. At this temperature, there is still a small portion of liquid water. If all water present in the ice cream were frozen, the ice cream would be as hard as an ice cube.